Welcome to a Sunday. I was messing around with adding an AI plugin to my Visual Studio Code because I want to convert some Arduino code to CircuitPython code. And boy, did that open up a barrel of monkeys. One of the things I found out is there is no consistency, even on the same provider of an AI, on pricing. It's all over the board. I did find that generally pricing fell into two categories. One was by token count, how many tokens used. Now, if you don't know, in AI, when you put a sentence into the request window, let's say on ChatGPT, all your words are counted and they're considered a token. So it processes things that way. Then other sites have a flat rate. So I was checking out I think the three main categories of AI, and that was ChatGPT family under OpenAI, Claude under Anthropic, and Copilot under Microsoft. Copilot and Anthropic had flat rates. ChatGPT, some of it had flat rate and some of it was all by token count, depending on the model you picked. So then I decided, well, I want to go for a front end for doing AI. So one of the front ends I was looking at was Tab 9, and I'll just bring it up in here. And I was very disappointed with them. So Tab 9 is a front end to a bunch of AI engines. You pick the engine you want to use at the moment of time that you want. And it has a flat rate. Something like $12 a month US, I think it is. But the negative on it was you had to buy a year. Positive on it, you get a 90-day trial in the Pro program. You're supposed to get a 15-day trial in the Basic, but it didn't work. And when I went to their ticket processing system, right, the first person that responded had me give them debug logs and all that stuff. Why I was locked into that my trial was always over. It never even started. And then I got to do one, and all that happened is, oh, you got 14 days of Basic, and if you want more, you can go to the Pro. Except I couldn't even get the Basic going. So this one ended up on my negative list, right, as being stupid because their support is stupid. So the other one I was looking at was one called not ChatGPT. It's like Chat AI, I think it was. Or Code GPT. It could have been that one. I think it was this one. And again, it was this one. I was having a hard time finding a pricing model. And it seems to, if you want any worthwhile integration with AI, you have to subscribe to the AI engine in question. Now, the neat thing about these things, where they were supposed to be, was they integrated and let you pick the models. But some of the stuff that wasn't clear about which models you ended up on, right? You can see some of them down here. Google, Meta, Anthropic. I find this kind of puzzling because the Google Gemini Code Assist one, you have to have a Google Code account on Google Cloud. So I'm not sure how they're even doing it. I did try out directly using them just to find out which ones. I had already played with ChatGPT, and I found it was piss poor at code. You describe the problems you want and whatever, and it goes on a tangent and doesn't do things. And the code that comes back doesn't even work. So I could equate that with maybe their model's out of date or whatever. Now, I don't know because they've changed ChatGPT from the 3.5 I was trying it out on. So we now have this ChatGPT-O and ChatGPT-O mini ones. They're supposedly newer, even exceeding that ChatGPT 4 Turbo down there. I find it funny here that they list Google and then Gemini. Google and Gemini are one and the same. Like, that doesn't give me confidence in that they actually understand which one to be using. Claude comes from Anthropic, right over here. And actually, I did a try on Claude on their site, and actually, I was quite impressed. I fed it a C code problem and chunk, and told it I want to convert it to uh, CircuitPython, and it actually came out with a bunch of steps I would have to do, some checks, basic framework of the code and stuff like that. It didn't attempt to actually do the whole 9 yards because it didn't know all the 9 yards. And it told me that. It said, I don't know what the camera driver is, and I don't know what this is, but I suggest you this, this, and this, right, to figure it out. And that was pretty good. I thought that was good. But on the free ones, the request window that comes up is not enough. I couldn't feed it all the C code I wanted it to feed. So I was trying to feed it the Arduino project for the ESP32 CAM, the CAM web server, and there's 2 C files and 2 header files, and one of the C files is like 1,200 lines long. It barfed on it because it has like a limit of like roughly 300 line input limit, right? So I thought, well, maybe if I integrate it with an integrator like this, I could do this. And yeah, I was just having issues because I wasn't subscribed to any of them. So this is one I was looking at. As I said, didn't work out. So the next one I looked at was one called, was it Genius? I think it was. Or, let me find out. AI. There was one. I did try Codium. Genie API. There is this guy, Genie AI. But I found it was very expensive. In order to integrate with the engines and stuff like that in here, they had I think it cost $20 a month or whatever to integrate. So I didn't go for this one. The one I'm leaning toward right now is called Bitto. It had high ratings and stuff like that. And they seem to integrate with a lot of common AI engines. You can see it here. But what was really, to me, was integrating with the Claude AI, which is talked about on their website, although not really in the plugin itself. You have to cross-check this with their own websites and stuff. So, and this one was 15 days free for getting started. And then if you wanted, oh, there it is. They added it up here. 15 days free, but if you wanted to go to their pro program, it was I think $15 a month with a the first I think 30 days free or something like that. So I'm leaning toward this one. I did try it out, the free bit part of it out a little bit, and it was working quite well. But I haven't settled yet 100% on which one is it to activate. So I'm not going to show using it. I'm just saying this is my research so far on this. The thing I was actually interested in also after doing some of this stuff was PyCharm's ability to have the project on the hard drive and then link in the CircuitPy drive. So I wanted to see if I could do this same stunt with Visual Studio Code. And I figured it out. The only key is before you go and open up the workspace for on the drive, and I'll show you how you add the CircuitPy drive to the workspace project that's on the hard drive. I don't mean hard drive as in the sense of spinny disks. I mean your permanent storage on your PC. You have to have the CircuitPy mounted first. Otherwise, you're going to get an error from Visual Studio Code saying, should I create this file? I can't find it, blah, 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 right? So first thing we do is I happen to have here a Pico 2, okay, on one of these Citron breakout boards. And what I did in the File Explorer, as I said, I created a new thing called VS Projects here in the File Explorer. And in VS Project, I just created a subfolder. There's nothing in it at the moment. It's empty. See? Nothing. Empty. Right? This is will be the base where we start our workspace and stuff. I haven't even created it yet. So we can go to Visual Studio Code, open this directory, and you'll get the preliminary stuff in it. But first, what I want to do is plug this in and make sure we have the CircuitPy drive on. Okay. And there's 2 CircuitPy drives, and I have no idea which is one. I always get this. So I'll try the bottom one and see what we get here. And settings, TOML. There's no Wi-Fi on here, so I doubt this is the right one. No, it is. Raspberry Pi Pico 2. Okay. Now I'll go to here and I'll open the folder. And yes, it should always appear on the wrong monitor. I'm going to open not the CircuitPy drive this time, but I'm going to go in here into my VS projects. And I'm going to open the folder I created for it. Yeah, I completely trust these authors. I'm the author, so why shouldn't I trust myself? Okay. No, we're not going to do this. So we have this empty folder. There's nothing in it at the moment. We're going to say add a folder to the workspace. And again, I have to drag this down here. Oh, shit. I'm not showing this. Damn it. Let's start over. I hate it when I forget to flip the windows. Okay, close folder. So I've got the Citron plugged in. Yeah. Go away. And I've got the Pico mount, CircuitPy mounted drive. So what we're going to do here in Visual Studio Code is open the folder. Drag this stupid thing. I really wish it wouldn't open it on that window, but I can't seem to stop it. I don't know why. That's not my primary monitor up there, right? This is. And it should be starting it on here, but this is stupid Visual Studio Code. Sometimes in Linux doing irksome things. So we go to VS Projects, we find our Citron folder, and we open it up. And I'm probably going to get a warning about that. No. Yep, there it goes. I don't want to do this yet. Okay. So there's nothing in it. And then we go and say, I want to add a folder to the workspace. And we add our CircuitPy drive. And we say, okay. Okay, you can see down here at the bottom where all the pop-ups are coming up that we found the bundle and everything. We downloaded it. We need to choose a board. So Pico 2. Here we go. Now we open a CodePy file up. We see the rest of our string of stuff that usually shows up down there show up. Now, since we are going to make it a workspace, we now can say File, Save As Workspace. We'll get that damn thing again. Now, I'm not going to save it in the CircuitPy drive. I am going to save it in VS Projects, that one. Okay. You cut it out. One moment, please. I think I got to turn that off because it's starting to annoy me. Disable. Here we go. So bundle's already there. The CodePy is already there. Let's just open a terminal for it. It'll now ask us where we want to open the terminal on. I'm just going to say on this directory. Okay. So if we actually change code in here, I'm going to open the REPL so we can actually see what's happening. We can go Control C, Control D. Hello world. Yep. Da-da. So if we wanted to blink everything on here, right? I think I have a sample for that. Let's go look at work. No, controllers. The other Pico. Because this is pin for pin compatible. So where are we? ASP, Raspberry Drive, RPI Pico 2. No, this one. So we have a bunch of stuff in here. No, not the backup 4. That's not a very good one. Well, there's a bunch of crap. Now we are having an issue because I think I don't have a library. No, a bracket? Really? Where? Oh, that's why. Because of this. There we go. It's not that I'm missing a bracket, I was missing a comma. So, I mean, I put some code in here. It's actually turned a bunch of LEDs on and stuff. You can see it at the top row there. So this now project actually exists, except for the CircuitPy drive that's over here, is actually exists on the hard drive. And you can see in the CircuitPy drive here, no .vs code directory got created or anything like that. Okay, but it is working. So kind of an alternate way to do your CircuitPy projects where all the control files that Visual Studio Code uses is actually kept on your PC, not on here. And you can upload libraries and stuff too. So in here, there's no library. So let's load the NeoPixel one, I think, on here. Because I think on this guy here, there's a NeoPixel right there. So I can actually go F1, show available libraries, Neo, install version. And it installs the NeoPixel on the controller where it belongs, not inside the control files area where Visual Studio is keeping the workspace. So that's pretty cool. I thought I had a better one for this. I think this one does. Let me get the files from this Raspberry Pi and put them on this Raspberry Pi. So we're going to close the workspace off just for a sec. Go away. And we'll go to here and we'll say safely remove. And I'll plug in this other Raspberry Pi. There's a whole bunch of junk in here. Okay. So it is backup number 4. I do already have it. So properties, safely remove. I don't need this. Plug this one in. Mount it. Okay, so we need out of work controllers, actually. RPI, CircuitPython, Pico, backup for Control A, but not the VS Code directory. Control C. And then we go over here to the CircuitPy and paste 24 items. Right into, please. We have 51 files to shift into our Pico there. Okay, all the copying's done. Now we have a better working example. Next projects. Yeah, it's okay. So now we go File, Open Workspace. From File. And we say this, and we say this, and we say Open. And that's the file we want to open. And there you go. More blinkies. One LED is not enough. Get a whole pile of them. So basically this Cytron board, LED is practically all the control pins, so you can actually mess with them without actually adding LEDs. Now this Pico 2, let's look at the boot out file for a sec. Yeah, so I've updated to 914. I really like that they actually added the boot.out file, not just from the hidden area where the UF2 file is put, but actually in the regular area too. So you actually know which version of CircuitPython you have on. And I think the last time I was messing with this, I was trying to get the Wi-Fi to be working. I think that's what I was working on. Because Cyclotron, you can add this board here. All of this is like a little tiny ESP board. Very basic one. It's like called an ESP0 or something like that. But it basically gives you Wi-Fi. So now let's do a different board. One I think I already have a .vs code file on. So what we want to do with it. So I'll close this workspace off. And I will safely remove the drive. Okay. So we have this ESP32S3 with TFT and the sensor on it. Okay. That cable's no good. We need USB-C. So I'm just going to make sure I have the right one just by opening this. Add for Feather ESP30 TFT. Yep, that's it. Okay. And we don't need boot outs. But what we want to do on this before we add this into our new project, right, we need a folder for it. So we can go to our VS projects here, and I'm going to add a new folder. So this is a Feather ESP32S3 TFT, like so. And then we can go to Visual Studio Code and say, I want to open that folder. Yes, drag it down here again. So we go to our VSC projects, and we open the Feather. Okay, so the Feather's loaded directory, but it doesn't actually have this in it yet. Before we add it, though, I found that you can get an error out of everything if you still have the .vs code directory. So that folder, delete. We don't need it. Everything else can stay in here. By the way, the secrets.json has been superseded by settings Tomo. It's still in here, probably because this was a transition feather where I was transitioning from one system to the other system. So now we can go back to, again, I did this. This is not starting out as a good Sunday. So I deleted the .vs code out of here is what I did. You just didn't see it. Sorry about that. I go back to Visual Studio Code and I say I'm going to add a folder to the workspace like I did before. And I will add the CircuitPy drive. And we see downstairs here, it's starting to do the bundle and everything. We need to choose a board. Feather. ESP32 S2, S3, S3 TFT right there. Okay. Now we're going to save. I can open the code file, for example. Duh. We're going to save the workspace. And it's going to ask us where. We don't want it in the CircuitPy drive. So we're going to have to go VS Projects. And we double click on Feather. We want it in this directory. And we say save. Okay. No .vs code is created. Everything looks good. Let's bring up a terminal for it. It will start the terminal in VS Projects. So nothing is set laid out. Only thing on the Feather is strictly CircuitPython files and its template. If you're ever wondering, the .f file system event SD and meta, that's part of CircuitPython. I think the metadata never index is for the Macs. And of course, system volume information, I think, is from if you plug the Feather into a Windows for that. But there you go. It's back in. And if we look at, we can see that it's doing a temperature read. Kind of hard to see. It's a little small. Where's my remote? Yes, this camera, you can go really nuts. So, but as you see, the picture just goes horrible. And holding the button down does not repeat. It's one thing the remote does. I have to click, 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 click. Lots of clickies. There we go. But now we have another project under our project tree. And go back to here. And if you look at our file manager here, right, in VS Project, we now have 2 of them. And you can keep creating more and more and more of them, right? But all the control files for the project are now on the PC. And this remains strictly Visual Studio Code. Now, on things like these feathers, the ESP2s or the Picos, right, or this Citron version, any of these types of boards, there's lots and lots of space on it. Okay, it's when you get to the ones with the SAMD21s on it, or the SAMD51s, space becomes a premium. Now, the other thing too is third-party versions of, let's say, the Pico. Let me see if I can root one out here for you. Let's say that one. One of the differences you always see on these guys is, here's the RP2040s right there. This guy here on this third party is more storage. So this one shows up, I think this is a 16 meg, whereas these guys I think are only like 1 or 2 meg. I would have to look up exactly what a Pico is. I believe the new Pico 2s is the same storage space. I can't remember if they increased the storage space. I think they did something with the PIO pins and the way they work, where this one was a little harder to make it work. And of course, this one has 4 cores, not 2. 2 of them are RISC-V, and 2 of them are ARM, whereas this one only has 2 ARM cores. And I think this one's slightly faster too. The ARM cores are slightly faster. So on a third-party one like this one, right? And the chip on here is like a WinBond. Kind of hard to read. It's like 250, 12.8, JVSQ is the chip. So the easiest way to look at this is actually look at the CircuitPython drive here in the File Explorer and do a properties on it. You can actually tell how much storage is actually on these things. Right there, 2.3 meg, 1% used. Okay. So let us close this project out. We're going to add this third-party one and find out how much space is on it. So where's our Visual Studio Code? There it is. So we'll now close this workspace. Let's make another project for this one too at the same time. So we can go back to over here and we can go to VS Projects, and I'll add a new one in here. Create new folder. And we will call this, what shall we call this one? I know it has a name. I mean, was it this one that was really good? Actually, there was another one I had that was even better. I'm not sure it's these purple ones. It was pink. I know it was pink, not purple. I think it was this one here. Yeah, this one. They look like they look like they're the same idea, but this one here is pin for pin compatible with the Pico. Right down to the debug pins, everything, but it has a lot more storage. This one's an open source project, and this one is some AliExpress knockoff. So we're going to do this one instead. So this one is the Pico boot. It is actually a third-party one. I'm hoping the guys who did this project will update the project and start producing or have produced on AliExpress the 2350 Pico. They actually make them Pico 2s. So we're going to call them Retro Boot Pico. Yeah, I think that should do it. So now we have the subfolder for it. And let us shut down this guy, safely remove. And now we're going to add this one here. Now I don't know which version of CircuitPython might be on here or what, so we're going to find out. Yeah, wine. Okay. So I need to know, I don't think even this is being flashed with Pico. Did I get the right one? The feather was USB. So even off the safe removals, this feather, for example, has not been actually correctly dismounted. You can see that with the error about the dirty file system. Some data may be corrupt. So we go we don't mount the thing. We do fsck.fat dev, and it is SDD1. Maybe I have to use VFAT. Should be able to. Why can't I do that? FSCK. Yeah, it should be FAT or VFAT. Shouldn't matter. Dev SD1. Well, something is definitely wrong in the file system because I can't even do a file check on it. I mean, I can mount it, but I can't check it. Seek to invalid argument. Yeah, something's not right on it. I'll have to figure it out later. This guy here, the retro boot. Now, if I go over to the websites and I go to... Where is one? Do I not have one open? Not the PyCharms. CircuitPython download. Thank you. Now, I don't know if this one's in this list. Yeah, that's what I thought. Pico. So if we scroll through here a little bit, I think I have this one here, the WEAC Pico variant with 16 meg. Let's see, PPI. I don't have. I do have this one. I do have this board. Oh, that's funky. No pictures. We have a web page redraw sign. WEAC Studio Pico. Now, I think the last time I flashed this guy here, one of them, I actually just used the stock Pico flashing for it. We can actually check for the... Wow, my web page is not also just disappeared, didn't it? Woo. Stupid OBS. Come on, properties. Let's get the web page. There we go. No, not that web page. Not that web page. Where's the right web page? There we go. Sorry about that. I'm having a good day today. Lots of mistakes. But yeah, this board is not particularly in here. No one's actually done it. But I have found, I think I flashed this with a standard Pico firmware and it actually worked. And I don't know what happened to the pictures down here. It's like we got some new boards and they forgot to put the pictures of the boards in. Oops. So let's go over back to File Manager here. I'm going to put this on, and I think if I just hold down the boot selector, I'm going to plug it in and let go, I should get the boot area on this. Yeah, RPI, RP2, right there. So, cut it out. Firmware, there we go. And we open this up. And on this side, we own up controllers. And I don't think, as I said, I don't think I have this in here. I can check, let's see if I have retro in here. No, I don't. So, as I said, I just borrowed the one from the Pico. Copy. And we go back over to our RPI2 and we say paste one file. Wait till this is done. There we go. There we go. And it should come up, CircuitPython. There it goes. And if we open it up, here we go. Now the real check is do the properties on this. But there you go. See? 15 meg. Instead of 2 meg. And another bonus on this is a built-in on reset button right here. And they still didn't do this on the Picos, but if you notice at the top of the Picos, where's the pinning? What pin is what? No, it's on the bottom. See it? Down there, up there. You can see it's all labeled. Newest Pico, same problem. Clone? Sure, it's on the bottom. It's also on the top. So you know. And it is pin for pin, this one. The regular Picos. Just more memory. Now that's one thing I noticed on the clone ones. The clones have the habit of doing all that part correctly, but they made the debug part 4 pins for some reason. I mean, you don't need 4 pins. So I when I did these, so for example, this one here, same one, I put in on, nope, not this one. Not this one. Not this one. Yeah, this is another one. Did I pin any of these with a debug on it? Maybe not. I don't think I did. Nope. But I could pin it, and then because this guy here has a passes the debug pins into this board, I could do that, and I could put this on here, and it would all be purple. We all know that if we color match everything, the bits work better. Yeah, right. If you believe that, I'm sure I have a bridge in Brooklyn that needs resale for all its scrap iron. And some real estate in Florida that's slightly wet, but I'm sure you can make use of it. So we've updated the firmware on this, and it's all looking good. Now we can add it to our Visual Studio Code. So we open a folder, and we go to our VS projects, and we add Retro Group Pico into there. Then we add a folder, and we add the CircuitPy we mounted. We choose a board. Now I said pin for pin. You're not going to find the retro in here. I'm pretty sure. It's not in here. So just use the standard Pico board. That one. Don't use the Pico 2 code because it's rigged for the way the cores work and the change in the PO. This one is exactly the same. So use that one. We open our CodePy. There's nothing in there. We connect to the REPL. If we say Control C and then Control D to run it again. Hello world. There we go. Everything is exactly as this Pico was. So again, I did that. I'm really charged. Like this is like 6 stupid foo bars in a video. Maybe I'm going for a record. But here's our purple one, working exactly like the real one, except more memory. A lot more memory. But even on a Pico, 2 meg is a lot of memory for it. Like, I mean, you could put a lot of code in there. This light demo on here, for example, you saw it was like 51 files uploaded. This one, wow, it barely made a dent in the file space. we were like 1% file space used up out of our space. So, and you can go to there's a GitHub link here. You can go to there and get the actual specs of the board. And actually, I just noticed on the bottom, you can actually hardwire wires for power on here. About the only thing I would see to add to this board, maybe a battery charger circuit. But then again, you could always just go to the Feather RP2040 and get it from them. And you can go overkill on Citron. This is another Citron board where they've added 2 Neos, a switch, a whole bunch of stuff, 2 I2Cs, speaker, and this one also has all lights on it too. So like this big board, it's actually doing what all these lights do also. It's a really glitzy board. Very small buttons on here though. Hard to hold them down. These ones I think are a little better. They're not pinching into your fingers. Maybe on a revised version, whenever they get around to doing it, they'll revise this and maybe put a little better buttons on. But what I'm really hoping for is that they take the design basically as is and add in the 2350 RP, the Pico 2. Then it wouldn't be an issue at all. It would be great. Really nice board. Okay. And this guy here. Oh, this was STM32 Black Pearl, I think it's called. Third-party version of it. I was when we were playing around with the STM interface. I was working on that. So I thought you might like to see an alternate way for Visual Studio Code to handle its projects. And we should create a workspace control file for this also at the same time. So we'll do a save workspace as. And these projects, retro, save. There we go. One of the reasons you actually want the .vs code director or the other one is these linkages in here. And this override right here. But there you go. So hopefully by next one, I will have signed up properly for Bitto and linked it in and started the web server conversion. It looks like it's going to be a fairly tough project because there's a lot of stuff in that web server code that has to be changed, like converted into CircuitPython, because it literally there's 2 whole sections in that thing. One, of course, is the web server component that you're connecting to with that ESP32 cam, and then there's all the subtle. When you look at that screen before, it was all the selectors on it saying, oh, do I want this mode, that mode, brightness, contrast, saturation. All those have to all be done. But I won't probably start that project until I go on my break. So, and that's in another week and 2 days or so. So, and then I'll have all the time in the world to do stuff like this. So, let's see, 49. So I'll let it go at this. If you have any questions about more on this Visual Studio Code alternate way, just let me know. I can do more based on it. And I'm really tempted now, after learning how to do it, to actually convert a bunch of my Visual Studio Code boards and stuff all over to this format. So then I guess I'll go call it. Yeah, sorry about all the mistakes. It's been a day of mistakes. So, but as you know, I tend to do these videos raw. I don't do anything. No editing unless I really, really have to. So we live by the mistake, we die by the mistake. So